Hi all, in this video we are going to discuss about what is Grignard reagent, how can we prepare it and how it will react with other substance. What is a general formula of Grignard reagent? That is RMgX. This R can be alkyl or aryl groups, alkyl magnesium chloride, or we can call it as aryl magnesium chloride. An interesting factor about this compound is it's called as organometallic compound. Organometallic. What is meant by organometallic compound, or did you hear about this? Right? Organometallic compound consists carbon metal bond. The bond formation happens between carbon and metal. Here this R group consists carbon which directly attached with the magnesium. And such kind of bonds are called organometallic bond, and the compound which have this kind of bond is called organometallic compound. So the carbon directly attached with the metals, that kind of covalent bond is called organometallic bond. And another thing, the bond between R and Mg, it's covalent, which is polar as well. This bond is purely covalent, and MgX we know very well that it is ionic. So one single compound consists both type of bond, covalent bond between carbon and magnesium, that means R and Mg, and ionic bond between magnesium and halogen. Now, how can we prepare this Grignard reagent? We can prepare it from haloalkanes or haloarenes. What is the general formula of haloalkanes? Rx. Right? Most of the case the X can be chlorides, bromides and iodides. When it is combined with metal, magnesium, and very important thing here, the solvent. We have to use dry ether, which means we should not use any solvent which can produce H+. Instead of dry ether, we can also use tetrahydrofuran as well, THF. We need only dry condition. Why we need dry condition? Why not aqueous condition? The reason next we will discuss. And here we will get this RMgX. Right? Example, we can use ethyl chloride when it is combined with magnesium. When it is react with magnesium in the presence of dry ether solvent, we will get ethyl magnesium chloride. Right? Ethyl magnesium chloride. Now, why we can't use water as a solvent or any protic solvent in the sense? Two reasons. First reason, this Mg can react with water first of all, because it's the most reactive metals, no? So it can produce MgOH twice, which is a base which can release OH minus. This OH minus can react with Rx in a way like substitution reaction. We can get alcohol as a product. First reason why we shouldn't use water. Second reason, this Grignard reagent is highly sensitive, highly reactive towards H+ donors. What happens when it is react with the H+ donors in the sense? We can get the corresponding hydrocarbon. We are taking RMgX. It is highly reactive towards H+. We can get the product RH, hydrocarbon. So what happened? This Grignard reagent will be stable only in the dry ether. If we are using water as a solvent, we will not expect the product. First reason, the magnesium can react with water. Otherwise, the Grignard reagent can get H+ from water and it can be converted into hydrocarbons. Because of these two reasons, we are not using water. Not only water, we should not use water or any H plus donors like carboxylic acid or alcohols or phenols. That is the main reason. Now, how it will react with other substance, right? So, as I already told you, this is highly labile towards H plus donors, right? So, this RMgX, I am just writing not only with water, also with other H plus donors. Like, I am taking first water. What will be the product? RH, the corresponding hydrocarbon, right? And next, I am taking carboxylic acid. I am taking acetic acid. It is also producing H plus, no? So, we will get RH. Even formic acid, any carboxylic acid we can take, we will end up with the hydrocarbon. And then I am taking alcohol. So apart from water, we can use any one out of this. We will end up with the corresponding hydrocarbons. Right. For this reason only, we are just storing this Grignard reagent in a dry ether medium. Okay, fine. Now, what is the use and what is the main application of Grignard reagent? We can able to see the Grignard reagent in all the chapters, right? Where we will use this? We can use this in the preparation of alcohols, carboxylic acids, aldehydes and ketones. One thing we can easily observe that new carbon-carbon bond formation happens. In Grignard reagent, we can able to make a new carbon-carbon bond, right? For this reason, it's widely used in the preparation of alcohols, aldehydes, ketones and carboxylic acid. Now, we are going to take this Grignard reagent, how it will react with aldehydes. I am just going to take formaldehyde. Formaldehyde, if I use, I can end up with primary alcohols. If I am taking Grignard reagent with other aldehyde other than formaldehydes, except formaldehyde, I can get secondary alcohols. If I am using ketones, what I will get? Tertiary alcohol. So using this method, I can able to prepare primary, secondary and tertiary alcohol. Now we are going to discuss how this preparation happens. So first one, I am taking formaldehyde. It's a kind of addition followed by hydrolysis. RMgX. This RMg bond is covalent at the same time polar as well. So when it is polarized, it will get partial minus and partial positive charge on magnesium. Metals are electropositive, right? So it will get R minus and then Mg plus. Now in the carbonyl compound, we know very well that carbonyl carbons are electron deficient because oxygen will attract the electron pair towards itself since it's more electronegative. Now the addition happens in a way that the negative attacks positive. And what will be our addition product? This O combined with MgX and then new bond form. This is what we have already mentioned. New carbon-carbon bond formation happens. This R is from our Grignard reagent. Next step, hydrolysis. When it is undergo hydrolysis in the presence of water, what happened in the sense, the hydrolysis happens in OMgX. It's O minus Mg plus. So in water it is H plus OH minus. In this way it's hydrolyzed. I am getting the product. OH. Along with this, we can get MgOHX as the additional product. So look at this one. It is our primary alcohol, RCH2OH. Right? Second one. Other than formaldehyde, if I am using acetaldehyde, propanoldehyde, anything, what I will get? I am taking acetaldehyde. In the same way, RMGX, first form, and adduct. Adduct is nothing, addition product. So here partial negative charge on R, partial positive charge on Mg, and in carbonyl carbon, positive charge, oxygen minus. Negative attacks positive. And we will get the addition product CH3, CHO combined with MgX, and this R. This R is from Grignard reagent. What is the next step? Hydrolysis in the presence of acid. Now hydrolysis happens here, Mg plus O minus. So OH minus here, H plus here. When it is combined, we will get what? CH3, C, H, R, OH. Nothing but we will get R, CH, CH3, OH. That is secondary alcohol we will get. As usual, this MgOHX will be formed as additional product. Now, how we can prepare ketone using this method? I am taking a ketone. We can take acetone or anything. I am just mentioning it as R dash. It can be symmetrical or unsymmetrical ketone, anything we can take. So this R is from Grignard reagent. As usual, the addition happens R minus Mg plus. Here it is plus, it's minus. Negative attacks positive, and we will get the addition product R dash, C, R dash. These two are from the ketone OMGX, and the new carbon-carbon bond formed. Next on hydrolysis. See, I am using H2O plus H plus or H plus plus H2O or H3O plus. All indicates only hydrolysis. Okay. In different reaction, they will mention it as H2O in the presence of H plus. Instead of that, H3O plus also. All represents only hydrolysis. OH minus H plus. And our product will be R dash C, R dash R, OH. That is tertiary alcohol formed. So using Grignard reagent, we can able to prepare what? Primary, secondary and tertiary alcohols. Right? Now, how can we prepare aldehydes and ketones? So here the same way, RMGX going to add to HCN. We know very well that HCN, carbon and nitrogen bond is what? Triple bond. Here if I write the polarization, where I will write plus and minus, here R minus, Mg plus. Here carbon nitrogen, which is more electronegative, nitrogen. So minus, here it is plus. Right? Same way, negative attacks positive. R combined with carbon, new carbon-carbon bond formation happen. So next case, how can I write the adduct? C, double bond N. Remember, the triple bond becomes double bond, and with the N, I am just including MgX. And here already one H is there. And from Grignard reagent, we are getting the R. New carbon-carbon bond formation happens. Now, next step, hydrolysis in the presence of acid. How it will? The same way. Here what I will get? Here I will get H2 and O. So I will get the product RCHO, aldehyde. Here I can write it as RCH double bond O, right? I will get aldehyde as the product. Along with that, what I will get? MgNH2X, right? Instead of this H, if I am using R, what happen? I will get ketones. Simple. So this R, MgX, going to react with RCN, alkyl cyanide or alkene nitrile. Here, partial positive charge on carbon, negative charge on nitrogen. Here, positive charge on magnesium, negative charge on R. So this minus attacks positive. Addition product, while we write, we should remove one bond. We should not write triple bond again. Okay. So it will be like C. We can take this as R dash, right? So Grignard reagent R and already existing R dash, double bond NMgX. So the next case, hydrolysis in the presence of acid, we can get what? Ketones. Along with that, we will get MgNH2X. So using this, we can able to prepare aldehydes and ketones also. Now, how can we prepare carboxylic acid? That is the next case. For carboxylic acid, we have to take CO2, carbon dioxide, which is linear, right? So when I polarize this, it's C plus minus. Here Mg plus R minus. So what happened? The negative attacks positive. The addition product will be what? C double bond O already there. We should not disturb it. With this O, I am just including MgX. With this C, we are including R from Grignard reagent. New carbon-carbon bond. Next, hydrolysis. What will be the product where hydrolysis happen? Here, exactly. H plus OH minus. We will get what? C double bond O, R, here OH. Nothing but RCOOH, carboxylic acid, right? So using Grignard reagent, we can able to prepare aldehydes, ketones, carboxylic acid. Other than this, we can also prepare some other products. Interestingly, I am taking Grignard reagent. I am going to react it with the haloalkane. Entire Grignard reagent reaction should happen in dry ether medium only because it's stable only at this condition. We should not use any other solvent, right? Okay, this R-Cl I am taking. It's a nucleophilic substitution 2. So what happened? This R minus, it will attack from backside, right? So backside attack happen and I will get R dash. Again the alkane, but number of carbon is different, no? It will be like more number of carbon than the Grignard reagent R. And also cyclic ethers I am taking. Here also the bond, when it is cleave, O minus plus. We know it is plus, it's minus. So minus attacks positive, minus attack positive, and we can get this cyclic compound will convert it into a linear. So what happened here? This R from Grignard reagent and here it is OMgX. Next on hydrolysis, what happened? OH, right? So we can write it as R CH2 OH. Nothing but R CH2 OH. We can able to prepare alcohol also. So there are a lot of preparations involving this Grignard reagent, right? This very important chemical. This Grignard reagent is around 125 years old, which was prepared in 1900. Okay, it's very important chemical in organic synthesis. We are going to solve questions from this Grignard reagent topic, right? So here, first question, methyl chloride react with magnesium, and what is the solvent? What kind of solvent we can use? Dry ether or any aprotic solvents, right? Tetrahydrofuran is a better option. Okay, what is the name of the compound CH3MgCl? That is methyl magnesium chloride. Grignard reagent prepared. So next it's react with methanol. In methanol it is not stable, right? Because it will release H plus. So this H plus will replace this Mg plus. So we can get this product, nothing but methane. So methyl chloride converted into methane. So it's a method to prepare hydrocarbons from its haloalkanes or haloarenes. Okay, next one. Chlorobenzene I have taken. What is a solvent? Again the tetrahydrofuran or dry ether we can use. I will get the Grignard reagent, that is phenyl magnesium chloride. On hydrolysis, what happened? It generally undergo reaction with water and we will get benzene as the product. So phenyl group converted into benzene. So next one, ethyl magnesium chloride reacts with formaldehyde followed by hydrolysis. Any Grignard reagent react with formaldehyde, we will end up with a primary alcohol. So how the reaction happen? So this R, it's partially minus, it's plus. And in formaldehyde, carbon is electron deficient, electrophilic. So negative attacks positive. And addition product will be like CH3, CH2, C, already it have 2 hydrogen, OMG, Cl. Next on hydrolysis, we can get this alcohol, nothing but CH3, CH2, CH2OH, that is propanol. Next case, methyl magnesium bromide reacts with acetone. Definitely we will get tertiary alcohol. How it will happen? CH3MgBr reacts with acetone. So the reaction happens, addition reaction happens at carbonyl carbon. So it is partially positive, oxygen minus, it's positive, it's minus, negative attacks positive, and the addition product will be CH3C, new bond formation, OMgBr. Next on hydrolysis, what happened? We can get tertiary butyl alcohol, that is IUPAC name 2-methyl propane 2-all we will get. Next case, this is our R. Remember, when it is combined with the COH, what happened? We will get, with the CO2 we will get COH. So you can directly write the product. With this R, COOH, we can get propanoic acid. So like this, we can able to prepare all kind of alcohols, aldehydes, ketones and carboxylic acid using this very important chemical called Grignard reagent.